In the realms of science and profound knowledge, the question of what existed before the Big Bang has sparked extensive debates and fascinated many for centuries. This colossal inquiry not only tests how we might understand the universe but also challenges the very limits of human knowledge. Imagine standing at the edge of existence, peering into the vast unknown, and wondering what lay there before our universe came into being. The event known as the Big Bang marked the start of time, space, and everything we know. But was there something before this hot, dense beginning? Some theories suggest the possibility of a state of nothingness, a quiet void before the universe exploded into existence. But what if something more mysterious existed before time itself? As we delve deeper into this question, science takes us on a journey beyond the early stages of the universe into concepts that challenge our understanding of reality. Physicist Brian Cox, known for his exploration of the universe's wonders, suggests that something truly astounding could have existed before the Big Bang, urging us to reconsider our perception of the cosmos. In this exploration, we will break down the science, theories, and astonishing mysteries that could shed light on what existed before everything. We'll look into concepts like cosmic inflation, quantum changes, dark energy, and even the multiverse. The answers we uncover may surprise you, but they could also open up new insights into our place in the universe. Get ready to dive into a world beyond imagination and science, where the unknown still lurks in the shadows, leaving scientists amazed and sometimes bewildered. To understand what might have existed before the Big Bang, we first need to examine what the Big Bang itself was. The Big Bang, as scientists describe it, was the event when the universe became extremely hot and dense, rapidly expanding to give rise to all matter, energy, and fundamental forces. When we look at the night sky, we see evidence of this hot beginning, with galaxies spreading out from a single point. But what caused this event? And was there a time before this dense, hot beginning? According to the theory of cosmic inflation, there was indeed a time before the Big Bang, and it was vastly empty and cold, much like an expansive vacuum. However, this vacuum wasn't completely devoid of anything. It contained an immense amount of energy that triggered the rapid expansion of space itself. This process, known as inflation, happened so quickly that it essentially set the stage for everything that would follow, from the creation of particles to the forces that govern the universe. But what was the nature of this energy? And why did it suddenly cause the universe to grow? Why did inflation stop? Scientists believe that this rapid expansion created regions of the universe, each undergoing its own Big Bang. Picture a fabric constantly stretching, with bubbles forming within it. Each bubble represents a separate universe, including our own. This idea, called the inflationary multiverse, suggests that there may be countless Big Bangs and an infinite number of universes. Ours is just one of many. This mind-blowing concept challenges how we understand the universe itself and raises the question, what else is out there? The notion of nothingness before the Big Bang is theoretical, not real, at least based on our current understanding. Even if we eliminate all matter, particles, and radiation, the universe would still contain something. It's filled with dark matter, dark energy, quantum fields, and forces we don't fully comprehend. Even in its emptiest state, the universe would still have some form of existence. The idea of true nothingness may be impossible according to current physics. Space itself has properties, laws, and constants that prevent it from being completely empty. For instance, the concept of zero-point energy refers to the lowest energy state of quantum fields. In this state, particles can still appear and disappear, creating subtle fluctuations even in what we consider a void. This challenges our understanding of emptiness, suggesting that even before the Big Bang, something must have existed. Researchers are just beginning to understand this possibility, and it may be one of the most surprising ideas in modern cosmology. Another fascinating theory is the idea of eternal inflation, which proposes that if inflation could create our universe, it might continue indefinitely. Cox describes an enormous inflationary multiverse where universes are continuously created and expanded. Imagine each Big Bang as a flash that ignites a new universe while inflation happens in different regions, forming countless others. This process could theoretically go on forever. This idea of a never-ending cycle of universe creation leads to the concept of a fractal universe, where each new universe gives birth to its own Big Bang. Each universe exists as a separate, independent space, unaffected by the others. For scientists, this hypothesis is both thrilling and unsettling because it suggests an infinite multiverse with no clear start or end. In this context, The concept of nothingness changes when we consider quantum field theory. According to this theory, the universe is not just a collection of matter floating in space. It's a complex network of energy fields that permeate all of existence, creating everything we observe. These fields resemble immaterial oceans, with tiny particles acting as waves or disturbances. Even in the lowest energy state, known as a vacuum state, these fields remain active. Particles can spontaneously appear and vanish, gaining and returning energy. This behavior challenges the idea of a true void. In a vacuum, fields continue to exist, meaning that even before the Big Bang, there was something. Dark energy, an unusual force currently driving the accelerated expansion of the universe, may have existed before the Big Bang. Some theories suggest that dark energy, in a much stronger form, may have triggered the inflationary phase, causing rapid expansion. The presence of dark energy implies that even if all matter and radiation were removed from the universe, this force would continue to shape the outer edges of spacetime. Dark energy could have been the silent force behind inflation and might even be the true origin of our universe. Cyclic cosmology is another hypothesis that offers an alternative to the Big Bang as a singular beginning. This theory suggests that the universe undergoes cycles of birth, death, and rebirth. In this model, the Big Bang is not a one-time event but part of an eternal sequence in which universes form and then collapse back into a singularity before expanding again. According to this view, our universe may have emerged from the remnants of a previous one. This continuous process of compression and expansion implies that there was never a definitive beginning, but rather an ongoing cycle of creation and renewal.